How you both doing? Okay. Kelsey, this is homework 5 graded for you. Thank you very much. Any questions? All right. In that case, that's to grade. In that case, here is the next one. We're going to start today. So, this is probably going to be the last homework assignment for the class. The last graded thing besides the next test and then the exam. So, currently, this will be due next Friday. And this assignment is roughly divided in two between looking at units and unit conversions and then more vectors. We're going to be working acceleration into our vectors. This will be less about vector addition and more about vector questions, just problems, physics problems that happen to involve vector components, which will be drifting slower and slower to all the stuff we're going to be doing at the start of the 1500. So, let's begin by looking at unit conversions, because units are going to come up in every math and science class that you ever take, and they are very important because if you don't do them right, then you crash them over into Mars. There is a story that is both tragic and hilarious in hindsight, where two NASA scientists were working on a Mars rover, and they were coding instructions into it, because whenever we send something to Mars, we no longer have direct remote control over it. You can't press forward and then it goes forward. There's 30 minutes of lag sending the signal there, and then 30 minutes of more lag to get another signal back. So once you get the rover on the ground, you tell it go forwards, and then 1 hour later you get the video footage of it going forwards. Which means that since we cannot manually control its landing ourselves, we have to pre-program all of its instructions in, including the units of measure for all of those instructions. So one scientist on this project was working in meters. And meters, the metric system, is the system that we're going to be using for most physics, for all of our working classes in general. The metric system comprises, as common units, meters for distance, which is abbreviated to M, grams for mass, which is abbreviated to G, and liters for volume, which is abbreviated to L. There are a bunch of other units, but these are the three most common ones. And this is different to the imperial system that is used in the United States, which has things like feet. There isn't really an imperial unit for mass, but gallons for volume. So we have two different scientists working in two different scales. I think the main scientist was coding in meters, but someone else was doing their math in feet. And just for a reminder, 1 foot is about yay long, 1 meter is about yay long. So the rover was gauging its distance from the ground based on one person's math, and then deploying its parachute based on another person's math. So when it deployed its parachute, 100 meters from the ground, it was actually 100 feet from the ground. And it crashed into the surface, and we lost $3 million, and we never get it back. So These are important. I hope most people will never, ever have the opportunity to make that kind of a mistake. But just in case, we're going to make sure that we can do it correctly. So, even ignoring metric versus imperial for a second, I want to at least show you the way that I convert my units, because it's going to just be the way that I write it on the board all the time. You don't necessarily have to write yours the same way. This is just the way that I do it. I employ what some people call the railroad method, where I end up building kind of a railroad track. Looking at the first three questions, we have three different things: 23 kilometers, 61 kilometers per hour, and 767 miles per hour. And we are told what we want to convert all these things into. And when I do these conversions, I say for the first one, we're converting kilometers into meters. I look up the conversion factor between those two things. So this equation here tells us that 1 kilometer is equal to 1,000 meters. We're using the metric prefixes here. They come up very often. We'll review them more closely in a second. But for right now, 1 kilometer is equal to 1,000 meters. I can then rewrite this as a fraction. If I divide 1 kilometer over the other side, I end up with 1 equals 1,000 over 1 kilometer. And because this is equal to 1, I can multiply whatever I want by this, and that doesn't actually change what the value is. It's just messing with the units. So I can multiply by this. I'm multiplying by 1, so the number isn't really going to change, but I can cancel out kilometers and replace them with meters. So 23 kilometers is 23,000 meters. And the other two railroads work the same way. They're just a tiny bit longer. Number 2, we have 56 kilometers per 1 hour. Same conversion between meters and kilometers. But then we also want to convert hours into seconds. 1 hour is 60 minutes. 60 minutes is, 1 hour is 60 minutes. 1 minute is 60 seconds. So 60 times 60 is 3,600. So very often I will just use this as a direct conversion instead of having to step through minutes first. So 1 hour is 3,600 seconds. Writing it like this cancels hours and leaves me with seconds on the bottom, which matches the unit that I am matched for, meters per second. And so that should give me, there we go. Carry too many things. So for the final answer, I have 15.5 repeating meters per second. What's happened here? Then, number 3 works very similarly. We are told the conversion between miles and kilometers. I've edited that just a little bit for space, but I suppose for thoroughness sake, I'll add the remaining step in. So you always want to set up the railroad to cancel out what you don't want and to leave you with what you do want in the correct position. So for number 3, we want to end up with meters per second. So we need meters at the top and seconds at the bottom. We start with 767 miles per hour. Miles, we know that 1 mile is 1.609 kilometers from the question. Orienting it like this, we'll cancel miles and leave us with kilometers. We want meters though, so we do have to convert kilometers into meters. Notice that since we're getting rid of kilometers and replacing it with meters, we are multiplying by the inverse. What? Never mind, I got it backwards. Multiplying by it this way, so kilometers cancels and leaves us with meters. And then, same as before, we want to get rid of hours on the bottom and leave seconds on the bottom. I imagine you've been doing conversions for about as long as you've been doing math. So if you have a method that works, please use it. You don't have to use my tactic. This is just the way that I'm going to write them, so I want to make sure people are at least familiar with it. So 1.67 times 1.69 gives me 342.8 meters per second. Which is, for a sense of scale, 1 meter is a little more than a yard. So this many meters in 1 second is the speed of sound. This variable is literally the speed of sound, which means that, so that's the speed of sound in meters per second. 1 sound wave travels this many meters, which is the same as saying over 1,000 feet every single second. So the speed of sound in miles per hour is about 767, which I didn't actually have memorized. So this is me being surprised, because I just didn't remember the number. Okay, so that's sort of my railroad system. Any issues with it? Okay. Now, the next batch looks at the metric system and converting between and around standard metric units. And let's see, we've got meters, liters, grams, meters cubed. And grams. So, the metric system was devised by a lot of very perspicacious European scientists to give a standard system for measure across all disciplines. And it's a very good system because we have these nice established units that are all a decent size, a known registered size, and we use the metric prefixes to scale them bigger and smaller, and the metric prefixes are all base 10, which is very convenient. This is different to the imperial system used in the United States, wherein 12 centimeters is 1 foot, sorry, 12 inches is 1 foot, and 1 foot is a weird 5,000 number of feet a mile, like two quarts to a pint, something like that. The imperial system is just different, and it's not super scientific, so we're going to stick mostly to the metric system. These are the 3 most common base units in metric, and so part 4 through 9 is about converting all of these numbers into these base measures. Are you guys familiar with the at least most common metric prefixes? Okay, the King Henry chocolate milk thing. Does that sound familiar? That's okay, that's okay. The most common metric prefixes that most people would have seen prior to high school are kilo, hecta, deca, the base unit. So So the normal unit lives there. Deci, centi, and milli. And there's a rhyme, not really a rhyme, kind of like the mnemonic used to remember the planets. There's a similar one here. King Henry died by drinking chocolate milk. Kind of morbid, not my favorite thing, but it helps me remember the order. And this original set right here are all spaced apart by a multiplier of 10. So 1 decameter is 10 times bigger than 1 normal meter, and so on and so forth. I think I have a chart for that somewhere. All right. So the 7 common ones are here in the middle. We go from kilo to milli. And there's 1,000 meters in a kilometer, 1,000 grams in a kilogram, etc. Meanwhile, in the opposite direction, 1 millimeter is 1,000 times smaller than a standard meter. And in a second, we'll just begin practicing these conversions. There are a couple on this assignment, though, that don't fit within those standard 7. So, just for the sake of knowledge, there are measures bigger than kilo and smaller than milli. You've probably heard them used before, even if you may not have seen them on a chart like this. From base to kilo and from base to milli, all those units are spaced a multiplier of 10 apart, which I've tried to show over here. But past kilo and past milli, we don't go 10 at a time anymore, because then we have too many of these things. So bigger than kilo and smaller than milli, we go by jumps of 1,000 instead. So going up, 1 megameter is 1,000 times bigger than a kilometer. So that's 1 million meters. I think that's the biggest one on this assignment. Yes, it is. Bigger than mega, we have giga, tera, peta, and exa. I know you can get commercially available terabyte hard drives. I have one in my PC. I think the military is working with petabyte storage. There must be, I don't know if it's a system that currently has exabytes. And then going smaller, micro is 1,000 times smaller than milli, and random English letters. So the symbol for micro, like the prefix itself, is a Greek letter mu. It's kind of like a fancy M. And then 1,000 times smaller than that is nano, and that's the one you'll see on the assignment. So 1 micrometer is 1,000,000 times smaller than base. 1 nanometer is 1,000,000,000 times smaller than base. So, looking at the assignment real quick. So, for 4 through 9, we are asked to convert to the base unit, the base unit for all these measured units. Grams is the base unit, so 4 is a trick question. 4, the answer is this. Then, number 5, we have 456 milliliters. So, convert that into meters. And put the mnemonic up here again. Nope. We're going from milli to base. The visual way to do it is starting at milli, the 1, 2, 3 decimal places to the left. So 1, 2,